we have to get them all right.
Alright. So, who are these? These blue packets. Oh, alright.
When are we finishing the 10 1 quiz?
I was holding that for a long time.
Okay. And anyone else need a blue packet? Alright, and then quiet down. Hi camera, I know you're running. Okay, if you were quiet please, if you were absent yesterday, you also need to get a weekly review quiz. Oh, okay. You should have got that yesterday. Alright, blue, because you did not. You did? Alright. Okay. Now, the answers to the blue packet are online. They're in chapter 10, and they're right under the BC topic list. They're called So You Think You Can Do Calculus, right? Okay. So here we go. Okay. Now, there's a couple rightos on this sheet. So as I walk through, I'll tell you what the rightos are. Well, let's hold off all, can we do one of these, can we do one of these, until after we go through the blue packet, and then we can do one of whatever you want, right? So just make a note off to the side if there's something you need to learn, and then we'll do after the packet, okay?
Where is it?
Do we not have to do the
What's it called?
I didn't do the example.
What is it?
All right, so here we go. So average value formula, you should all know the average value formula. Just remember, whatever B minus A to you're going to go to A from A to B, of whatever you want the average of, right? So if I need the average rate of change of F, then that means that F prime, the rate of change of F, would go there, right? Whatever comes after the word average, that's what you want the average of. So that's what goes there. The units for an average value are the same as the units of whatever you put in here as your function, right? So if your function is measured in dollars per day, the average value of it would be dollars per day. Okay? All right, washer method, shell method. I have always done washer for dx and shell, or for horizontal axis, and shell method for vertical axis. But yesterday after school, I had the fun time of doing a shell method horizontal axis. I have to say, I really needed to brush up on my shell method horizontal axis skills. So it was funny. You don't usually encounter problems where they force, but they forced on this one. It was in the multiple choice, right? So I wasn't a real big fan of it either. But I gotta say, once I kind of backed up, remembered how to do it, it really wasn't hard. It was just a matter of remembering how to set it up. So I guess the advice I have there is just be aware that it is possible that they might force you to do a washer with a dy or a shell with a dy, right? So just be aware. All right, arc length, bam, 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 rectangular, parametric, polar, you need to know arc length, right? Okay.
Can you keep up the whole
Okay. PVA, almost every PVA, I'm going to say every PVA problem that I have seen so far on BC exams has been with vectors and parametrics. I haven't seen any yet that were just regular old single direction linear PVA. It doesn't mean it's not there, but I will just tell you to be prepared for the vector version, right? So be prepared for two-dimensional x of t, y of t for position, x prime, y prime velocity, x double prime, y double prime for acceleration. So just be prepared. It's not harder, it's just that there's multiple components now. All right, ball flight. To be honest, I don't think this is an AP topic. So, it is not on the College Board's list of topics. I can't find it on any AP exams. So I'm thinking this will be on your Chapter 10 test, but I wouldn't worry about it for your final. Now watch, it's like on there. I apologize profusely in advance if it's there, but I have not yet seen it.
If it's there, could you help us out?
If it's there, I might be kind.
I would be quite keen.
Well, we don't want that.
No,
So, okay.
I don't know the phrase.
All right.
So do we take notes?
Okay. All right. Slope of secant, slope of tangent. Slope of secant is just old-fashioned slope. Slope of the tangent is the limit as x approaches a specific value. It's really, right, it's slope without a change in x. It's, right, slope at a point. So one of the things that this kind of made me think of, I just put on one of the limit formulas for slope of tangent. There's two of them, right, for definition of the slope of the specific derivative. It made me think of those three definitions of a derivative that we learned way back in September. And one thing that you just might want to have in the back of your mind in case you've forgotten it is to know your general definition of a derivative. The fact that a derivative f prime of x is just the limit as h approaches 0 of f of x plus h minus f of x over h. Just kind of knowing that and recognizing that that's a general derivative can sometimes help you, especially with multiple choice. So, I've never seen it free response, but I've seen it multiple choice. Okay. Riemann sums and trapezoids with indeterminate limit forms in the middle, right? Okay. Riemann sums are rectangles. The area of a rectangle is just width times height. The only types of Riemann sums you are required to know, and this is from the College Board, are left, right, and midpoint. And then you have to know trapezoids. There is no Simpson's rule on the AP exam, or on the final exam. Okay, Simpson's rule is not an AP topic. But you do need to know trapezoid rule, and one of the things that I learned is that a lot of Thomas's students are using a formula for trapezoid rule, which doesn't work if the widths are unequal. And since the early 2000s, the widths are almost always unequal. So you need to be prepared to do trapezoids with unequal widths. So you can't use that 1/2n thing, whatever it is that you guys learned. You need to do 1/2 times the width times the sum of the heights for each trapezoid, and each trapezoid needs to be done separately. All right? So if that's something that is bothering you, make a little note, and then when we're done with this, we will do a trapezoid.
Just a question, but what are the indeterminate forms based on?
Okay, indeterminate forms are when you have a limit, and if you plug the x in and get one of these, right? So if you get 0 over 0 or infinity over infinity, you know to use L'Hopital. If you get something to a power, 0 to the 0, 1 to the infinity, or infinity to the 0, that's when you let it equal y, take the log of both sides, and then you put the exponent in front, right, and manipulate from there. If you get 0 times infinity, that's when you want to move 1 to the bottom so that it becomes 0 over 0 or infinity over infinity. If you have infinity minus infinity, it's usually fractions, and you just combine the fractions, and you go from there. So there's all your indeterminate limit forms. Logistic differential equations, you really should have a fairly decent memory of both of these. So the differential form and the solved form for the logistic model, right? Make sure you have the 1 in the right place, because a lot of times, remember, they like to kind of mix it up, and you have to factor that ky out, or just the k part, or just the y part. So make sure you have a 1 here, so that you can identify what's k, what's l, what's y. And then here, you need a 1 here, so you can have, that's your limiting value, that's your b, that's your k. If you have this, you can derive this, but it's not an easy separable differential equation. It's doable, we did it, but it's not super easy. So it's so much better if you just know this, right? So I would just know this. All right, just make sure you have a 1 in the right place before you start. Slope fields. When matching a slope field to a differential equation, make sure you're matching the slopes, not the shape of the graph. It was the ball. There was a multiple choice problem where they didn't give you differential equations to match to, they gave you equations to match to. When you're matching straight to equations, then you have to actually check the shape. So it's kind of a weird thing, but if you have a slope field that looks like an x cubed, if it's a multiple choice and your functions are all dy dx's, then you're matching to the slopes. You're literally checking to see which function produces those slopes. It would probably be an x squared, right? But if you have an x cubed and you're matching to y's, means the differential equations have already been solved, then you're going by shape. And you would want to pick the one that is an x cubed. So most of the time you match to dy dx, but there was one in one of your packets where it was matching to a y, so just be aware of that. All right, the big 6 derivatives are the trig functions. Make sure you just know all of those. The big 6 integrals. Make sure you know all those. It's been a while since we've said, hey, the integral of cotan is natural log absolute value sine, right? So make sure you know them. That could be a multiple choice difference for a point. A sequence, I just wrote what it was, right? It's a function where the inputs are integers, right? So, positive integers. Sequences converge if the limit exists and diverge if the limit doesn't exist. They're really easy. Sequences are easy. Euler! Euler wasn't that long ago. So we did Euler in chapter 8, even though it's in your book in chapter 6. Euler is the one where you are approximating a solution to a differential equation. I will tell you personally, I find that the formula for Euler is super easy and super fast. And if I were you, I would take the 30 seconds and learn that formula. But if you can do Euler with tangent lines and you're comfortable with that, just do it. Tonight is not the night to learn new stuff, right? Like, ooh, I think I'll learn a different way of doing Euler, right? That's not the time. That's for later. But anyway, yeah, if you can do Euler and get it right, then do what you're doing. So I personally have found that the formula is the fastest and easiest way.
No.
Okay. Integration by parts. You know the integral of u dv is uv minus the integral of v du. Just remember, please, tab is your friend, right? Use tab. So whenever you have an integral of a polynomial times an integrable function, tab method, right? Go with tab. Integration by parts, to recognize when you need to use it, it's most often used when you have an integral of a product, right? Not always, but often. Integral of a product is either going to be a u sub or an integration by parts. Right? It's also used if you have an integral of something that you just don't know how to integrate any other way, like natural log or inverse trig. Then you do integration by parts. All right, partial fractions. One of the things that I wanted to make sure I reminded you about with partial fractions, remember it's when you have an integral where the denominator is factorable, right? But you have to make sure that the numerator has a lower degree than the denominator. If the numerator has a higher degree than the denominator, what do we always do first? Long division. Long division, right? So if the numerator is higher, do your long division first, then you could do partial fractions on what's left, right? If the bottom is factorable. Triangle rule. Triangle rule is Mr. Thomas's way of saying trig substitution, right? That's trig sub. So trig sub, to me, if I see an integral of a square root of something plus or minus something, and there's not an obvious other way to approach it, then trig sub might be your best bet. And that's where you take each of the items and you put them in the right spots on a triangle. Depending if you're adding, they're the sides. If you're subtracting them, one will be the hypotenuse, right? And then use Pythagoras to find the other one, and then you attach trig functions to the various things. Rewrite your whole integral with trig, and then evaluate. So that's triangle rule. I didn't know how to put that in the blank, so I just said, you know, go with it. All right. Integral and derivative of natural log x. Derivative of natural log x is 1 over x. If it's the derivative of natural log u, then it's u prime over u. So if it was like the derivative of the natural log of x squared, it would be 2x over x squared. Right? The argument goes on the bottom, the derivative goes on top. Okay. All right. Integral of 1 over x is natural log x. Integral of natural log x is integration by parts. Right? So x ln x minus x. All right, I just wrote out general formulas for Taylor and Maclaurin polynomials. They are the same, except Maclaurin's are around 0. I found out the kids that went to DC found a book by Maclaurin. Yeah.
It was in Jefferson's library.
That's pretty cool.
Yeah.
You guys, I wanted to get a picture. I would have loved a picture of you guys all like holding the book.
You
We can't touch them.
You can't touch them?
No, it's in the glass case.
Really?
You just like take a picture of it.
Wow.
Adds to the intrigue.
It does.
That sure must have been.
Wow, it's too bad. Wouldn't it be fun to like actually look and see what it was?
Yeah.
Wow.
Oh,
Wow.
yeah. Oh man, whoops, I
Why
spilled
didn't
coffee.
you break
Okay,
the
yes,
glass?
okay.
Should we memorize the integral with O1x? Or just,
It's so easy to find that, and it doesn't come up that often that I wouldn't worry about it too much. You can always just derive it with the integration by parts. That's up to you. It's honestly, I would gauge how your brain feels, right? Do you feel like you have enough already memorized and you don't want to push any more in?
There's no such thing as too much memorization.
Okay. All right.
just like, okay.
L'Hopital, right? I think you all know L'Hopital. One of the things he didn't mention in here was improper integrals, right? Make sure you know how to do improper integrals. That kind of relates to L'Hopital a little bit, but improper when you have an integral where the limits, one of them is infinity, or where you have division by 0, right? And you have to rewrite as a limit. So anyway, L'Hopital. Power series for sine, cosine, and e. I never made you guys memorize power series for sine, cosine, or e. But I had to do, one of the multiple choice problems made a very strong case for memorizing the power series for sine, cosine, and e. So I was able to memorize them honestly in under 10 seconds. They're very simple to memorize, and I'm going to give you a trick, right? Because the tricks help. So here's my trick for memorizing the power series for sine, cosine, and e. Let's start with e. E is easy, right? Okay, so that's my trick. E is easy. It's the most straightforward of all of the series. You literally just, it's just 1 plus x squared over 2, x cubed over 3, x fourth over 4, x fifth over 5th, right? It's very, but with factorials. It's very straightforward. It's just like the most plain Jane of all the series. Sine. Here's how I remember sine. First of all, sine and cosine both change sign. Okay, so they're both alternating series. Sine is an odd function. Did you guys know that? It has origin symmetry. So because sine is an odd function, all the exponents for sine and all of the factorials for sine are odd. Right? Yeah. Oh, good. Huh? Okay. So sine is an odd function. So you just pick all the odd exponents, 1, 3, 5, 7, blah, 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 and alternate the signs. Okay? Cosine is an even function, has y-axis symmetry. So cosine, you pick all the even exponents. 0, make sure it's 0, right? Exponent, 0, 2, 4, 6, 8, blah, 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 blah. Both of them start positive and then alternate, minus, plus, minus, plus. You don't have to memorize them. It doesn't take that long to build them. But there was a multiple choice where you had to like pick which one or something, and it was a bunch of different ones. And if you knew them, it made it a lot easier than having to derive all of them. So anyway, so if you want to memorize, by the way, speaking of power series, if they ask you for the general term you would write plus dot 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 plus and just this without the sigma, right? So the general term is like the term with the x's and the n's, but without the sigma. It's like the series without the sigma. Okay. So that's your general term. All right, Newton's method. Newton's method, different from Euler's method. Newton's method is finding zeros with tangent lines, right? We did it last semester. So you find the equation of the tangent line, set y equal to 0, find where it intersects the x-axis, that's solve for x, that's your next x, right? Plug that into the function, get your next y, get your next slope, find the next equation of the tangent line. Find where that intersects the x-axis, right? You set y equal to 0, there's your next x, right? And you plug that into the function, get your next at y, get your next slope. Yes?
For the AP test, did they tell you which point to guess at first, like your first x value?
I think so. I would think it would be awfully hard for them to grade if they didn't.
Yeah.
So I would think so. I'm kind of making an educated guess on that. One thing I can tell you for sure is one thing I have never seen, and it's not in their list of topics by the College Board, is they never asked for the, do you remember when we calculated the error, let's see, we did error using trapezoid method, and we did error with Simpson's. The Simpson's method is not on the AP exam, right? It's not an AP topic. But we also did those error formulas for trapezoid. Someone asked me about that today.
yeah.
That's not on there. Okay? Yes?
Is there a possibility of repeating these?
Make a little note.
Just to-
Yes. Okay. Okay. If you need to know all of your series convergence and divergence, blah, 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 look at the Maclaurin. There's no way I was writing all those in those little blanks.
Scroll at the centimeter.
Can you explain limit, comparison, converge, and diverge?
You asked for it.
Where are you?
Series convergence or divergence?
And what do you want to know?
Converge and diverge for limit comparison.
Oh, for the limit comparison test?
Yes.
Oh, okay. Thank you. So for the limit comparison test, it's okay. You have some series, right? And then you find a series that is similar to that series. Usually it's a series when you're adding or subtracting a constant, right? You like remove the constant or whatever, okay?
Can
You
you
put one over the other, take the limit as n approaches infinity. If that limit, oh my gosh, you're really testing me. If that limit is a positive finite number, then they match. So if the one converges, the other converges. If the one diverges, the other diverges. This is all on the Maclaurin. Okay. All right. Lagrange, there's a Righto on this, okay? So I can't get my marker to work on here, so I'm going to put it over on the board. So those of you watching, this is wrong. It should say max with an absolute value. And it's funny because I had just done a Lagrange before writing this out, and I just flaked and did not write it. But it should say max of the absolute value of the n plus 1 derivative. Right? Whenever you see an n plus 1, a number in parentheses as an exponent of an f, it means that derivative. Right? So it's the error is less than or equal to the max of the absolute value of the n plus 1 derivative of z over n plus 1 factorial times x minus c to the n plus 1.
What's z?
Z is any number between x and c. There is no way to find z, so you need to find the max of that derivative, the n plus 1th derivative, between x and c.
Can z
What's
equal
the
x
point?
or c?
Will that be on the test?
Z is a number you will never be able to find.
Yeah,
So it's like saying the derivative, you take a derivative, you always have to multiply by k, but you can never find k, so you just multiply by 1 instead.
Isn't that awesome?
So I just made my own theorem, Miss Price, is that what you were saying?
That's
Can we call
Like,
it?
I find it
All right,
stupid, like
put a
what's the
little
point
note
of making
next
I
to
just-
it, and we'll do a Lagrange in a minute.
Is it on the AP test?
Yes. Yes. Lagrange is. That's a definite.
Just
That's
ace
on the
everything
test?
else and then you can get the
Lagrange is
Lagrange.
on everything.
Not fair.
Yeah. By the way, guys,
Shucks.
Lagrange and you know how you love the alternating series, the error
Yeah.
theorem,
Yeah.
right?
That's amazing.
They're almost the same thing. Alternating series says that the next term of the Taylor polynomial, or whatever the series is, right? Well, what would the next term be? It would be x minus c to the n plus 1 over n plus 1 factorial, and it would be the n plus 1th derivative evaluated at c, right? So it's almost the exact same thing, it's just that this is applying, saying it's not an alternating, so we just have to take the maximum possible value of this. So, yeah, okay, I got that, but it really is, they're very similar, closely related. Okay, so we'll do one of those. Yes?
For Lagrange, would n usually approach infinity, or would it be?
No, n is a finite number.
Okay.
Yes. All right, good question. Radius and interval of conversion. On one of your weekly quizzes, there was a question, and it asked you guys to write the interval of conversion for some series. Some of you used the geometric series test to find your interval of conversion. You got the answer right, but you lost points because you didn't use the correct test. One of the things I have learned is that you may never ever assume that a series is geometric unless you're actually explicitly told it's geometric, or you create it from the sum of a geometric series, right? If you do the a over 1 minus r and build the series, or if you're said, you know, p of x is a geometric series, right? Whatever. So if that's true, you can do geometric series. If that is not the case, you have to do ratio test, all right? No shortcuts. You have to do ratio test for your intervals of convergence. Yes?
Wait, even if it's like completely obvious, like an x over.
How is it odd? I have yet to find any source that can tell me how to know that a series, a power series, is geometric by looking at it.
Like, if you just had like x over something, that, like when, don't you just know that that's geometric?
So with nothing up front, you just look like
Or just like a
5
number up-
times x to the
like a
n, you have
number
the
up on
sum.
something,
Do you really think they're going to give you 5 times x to the n?
I hope
Yes.
so.
Yeah, they're not.
Wait, they're not?
They could trick you
They could.
by giving you easy problems.
And yet the ratio test would still work just fine and be just as easy. So let's just go with ratio just to be safe. Because that's what I was told.
What
And I'm
about
going with
instinct?
it. Okay. Ratio test. All right. I didn't know what to put for vectors in component form, so I just wrote a vector with components. So there you go. All right. I don't know if you wrote, because you spent an hour on it, so you spent more time than I did. Did you write anything good for it? No. Okay.
I wrote an example, because I thought you could use it.
Well, that's
really fun.
You were super overachieving. You were gonna so ace this final. You were gonna like break the curve on finals. Yeah.
Please don't.
Yeah.
No, I'm probably the last person.
Okay. All right. Speed. Speed is the absolute value of velocity. One of the things we haven't talked about in a while, in the old traditional PVA problems, sometimes they would ask you if the speed is increasing or decreasing. Speed is increasing when velocity and acceleration have the same sign. Speed is decreasing when velocity and acceleration have opposite signs. All right, so just know that if they ever say, hey, is the speed increasing? You have to like say, is the speed increasing at t equals 5? You would find v of 5, you'd find a of 5, and look at the signs. If they're the same, it's increasing. Speed in parametric form, square root of dx dt squared plus dy dt squared. Good connection. It is not, but it is related to arc length because arc length is the integral of the square root of dx dt squared plus dy dt squared, which is also the same thing as distance.
Oh, okay, okay.
Which kind of makes sense, right?
Because you're like
So-
Oh, you're
Yeah.
taking the integral of the
So-
speed, yeah.
So anyway, so the integral of the speed is distance,
Or
and it is
displacement.
also, no, not displacement, distance.
Distance? Okay.
Distance. Because this is an absolute value. Whenever you have a square root of x squared, that's the same as absolute value of x. Speed, like, think of it like this. Speed is the absolute value of velocity, right? If we just took away one of the components and just did dx dt squared, say it's just horizontal motion, the square root of x prime squared is the same thing as the absolute value of x prime, which is the same as the absolute value of the velocity, right? So these are, this is, when you square and take the square root, you're doing absolute value. So this is taking it and making it all positive, so it will give you distance. If you were asked for displacement, I have yet to see a displacement problem on a vector question. However, if they gave you one, they would probably give you displacement parametrically. They would say, what is the horizontal displacement, right? If they asked you for horizontal displacement, that would just be the integral of the dx dt, right? It's just the integral of velocity. So it would just be the integral of that x prime. So if they ask you for vertical, it would be the integral of y prime. If they ask you for distance, then it's the integral of this whole thing. Okay, parametric rectangular, you got it. Area of a polar, we just spent like a week on it, so you should do that. Critical values are where the derivative is 0 or undefined. Almost done, last page. Concavity, we went over this yesterday. Please make sure you know the relationship between f, f prime, and f double prime. Make sure that you know that when a function is concave up, it means that the f prime is increasing, which means f double prime is positive. If a function is concave down, f prime is decreasing, f double prime is negative. All right, trig, formulas, yay. All right, those are just identities. I can say with 99% assurance this is not an AP topic. This is pre-cal. This will be on your chapter 10 test, but it will not be on your final of the AP.
It's just ridiculous.
All right.
Why?
Differential equations. Please just make sure that you know that. Whoa, woo. Okay.
It's a little eccentricity.
Please make sure you know that. That differential equations are worth a lot of points. Make sure you know that when you separate the variables and integrate each side, that you have to write a plus c on that line, and if you don't, they stop grading right there. Right? So just make sure you know that you separate the variables, integrate both sides, write a plus c, then you plug in your given point, solve for c, solve for y, make sure your answer is a function. Yes?
Do we have to know eccentricity?
I haven't seen anything that would help you with it. Okay, let's just skip down for a second. Because I talked to Ms. Johnson about this. So I asked her, of all the conic stuff, what is on the AP exam? And she said, none of that standard formula stuff, none of this stuff. Once in a while you might see a polar equation, like say of a graph, and it ends up being a graph of a conic and you have to find an area or something, right? But then they usually just like give you the graph anyway. I don't know. I don't know if there's a real benefit to knowing the polar equations of conics or not. So maybe knowing that, you know, if your eccentricity equals 1, it's a parabola will help you. I don't know. I don't know. But I know that there's very little, if any, pre-cal, if there are any pre-cal questions on the AP, right? It's all calculus. I mean, they only get us so many questions to cover a whole year of calculus. They're not going to waste them on pre-cal stuff. Yes?
If that usually doesn't appear on the AP test and stuff, would we expect something like that on the test?
I would say no. Now, I haven't taken tomorrow's test. I've just like flipped through it.
Okay.
So, again, I apologize profusely if it's there.
You should like go
I don't
through it.
We should we should take the test.
If I was a student in AP Calculus and I had a lot of stuff to study, that would not be where I would spend my time.
Just a big X.
Okay?
Wait,
Alright,
okay.
going back. Yes?
What are your like top 5 things for like so
Okay, let's finish this and then we'll get into that. Alright, okay, we're almost done. We're almost done. Yes?
I guess you'll get there.
Okay, good. Alright, so fundamental theorem of calculus. The first fundamental theorem is just the definition of a definite integral, right? Integral from a to b of f prime is f of b minus f of a. You have to know how to do a definite integral. I didn't write, and I didn't even think to write, but I should have written the second fundamental theorem of calculus, which is always on the AP exam. right? SFTC. So make sure you know SFTC. Right? Make sure you know it. Where it's when you have a derivative of an integral with variables in the limits, right?
Could you write that down?
I can write it over here. The whiteboard is not working with me writing on it, but I will write it right next to it. If anyone who's near the camera wants to, once I write it, wants to turn the camera and show those out there what it is, that's fine. So SFTC says the derivative of an integral where variables are in the limits, like that. So you take the top limit, plug it in, times its derivative, minus, take the bottom limit, plug it in, times its derivative. Right, that's SFTC. So, most of the time, one of those limits is a constant, and then the derivative is 0, and it just goes away, right? But I can't make any promises. Yes, you multiply by the derivatives of the limits. All right, good. All right, turning the camera back. I didn't know what to put for differentials. I can tell you this. After going through the list of BC topics, I did not see any kind of like propagated error. Do you guys remember when we did that?
No.
The estimated propagated error. Yeah, when we were learning differentials. I haven't seen that anywhere. So I wouldn't worry about that too much.
says that she's never seen you show up tomorrow.
I know. Yeah, wouldn't that be funny?
The whole test is just a
If that happens, the whole class is just gonna put their pencils down, get up, and do a mass exit, right?
Oh, no.
We're gonna ask the wrong answer.
I thought we did that
For
one.
Harrison on the trig test, I
one
specifically
season,
asked them
I
why did
don't
there
know
be
that.
graphing, you have no graphs. I put the very first page, 2 graphs.
Yeah.
Oh, yeah, there's always like
Problem
with the month,
Yep.
like January,
Okay.
February.
So, differentials, basically, it's just the components of the derivative, right? So, if y is sine x, dy dx is cosine x, right? You can write it as dy equals cosine x dx, right? The dy and the dx are called differentials. So, anyway, it's not that important in this context. All right. Mean value theorem we have done to death. You should all know it. Continuous differentiable, slope of the tangent equals slope of the secant. All right, plus c, just make sure you always write it. Inverse functions. Let's turn the camera for 1 second for inverse functions, because you were never taught derivative of an inverse. You were taught it in my class for like 12 seconds. So, quick example of inverse derivatives, right? Here's how these are usually presented. Suppose f of x is x cubed minus 3x plus 2. And p of x is the inverse of f of x.
I remember this.
Find p prime of 3. Right? Often they will say, given f of, don't check the math, it won't be right, -2 equals 3, okay? Just something like that. All right, what do you do? There is a formula, but let's not learn a new formula right now, all right? We know inverse functions, first thing you always do is swap x and y. So you swap x and y. So you have x equals y cubed minus 3y plus 2, right? So now